Alright. Hello? Can you hear me now? Dude, this fucking stream delay is about 30 seconds, I'd say. So let me know when you can hear me. Okay, cool. So, anyways, I guess what I want to do today is work on Spectra and try streaming this live so I can look back to how I was programmed, because I'm such a fucking good programmer. I just want to see how the fuck I can get so good. Um, this is Spectra. I had a video about it. So it's a very early version, so I want to make some improvements to that. This is going to be the task for today. So let's see. What's on the to-do list? Okay, fix TAA bug. I guess I should talk about what TAA is. So TAA stands for temporal anti-aliasing. The idea of anti-aliasing is that, so say we shoot one ray for each of our pixel at the pixel centroid. Now, if you know signal processing, then you know that's not enough. That's not enough sampling frequency to avoid aliasing. So what you really need is a lot of samples at different places within your pixel. But if you want to sample the same pixel 4 times, that means the performance is going to go down by 4 times. So the idea of temporal anti-aliasing is that for each frame, you sample a different location in the pixel. And you distribute your sampling pattern throughout multiple frames, and you slowly average these frames. So that effectively you have this super sampled signal at the end. Now, I think the problem I'm encountering, let me just try to reproduce the bug I have. So it looks pretty nice here. I guess it only happens with bright light source. Let me just go to demo, say set to 10. Still can't see it, huh? Well, probably can see it here then. Cornell box, nope. Okay, interior. Let's try this one. Alright. So you can see the edge of this table is anti-alias thanks to TAA. But when you look at the outside, you can see there's this jittering. Now I'm not sure if this is actually a bug or this is just the problem with TAA. I'm gonna try to see if I can do something regardless. So I think the first thing we should check is the trickiest bit is how to correlate current samples with history samples. So it's a step of back projection. So you kind of know, so the idea is basically you have a previous frame, you have a current frame. So you know the pixel location of the current frame. You want to ask this question, okay, so where was this pixel in the last frame? This is the tricky part, and I want to just look at how I was doing that. So I think it's going to correlate history. Fact. Let me actually check my TAA code first. So okay, here's the bilinear filter for the sample. Here's the neighborhood clamping. so that we reject any stale history. Um, nothing really stands out to me. How was I? Hmm. So I guess the first thing we can try to do is, so I remember, besides the bilinear filter and the neighborhood clamp, the very first temporal anti-aliasing paper had more than that. So I think it's Brian Karras. Let's go do his slides, see what they have. Okay. Jitter, Houghton sample, right? Exponential moving average. Tone map, we have that. Unjitter. Are we unjittering? Yes, we are. Hmm. So I think this is our problem. We're not. No. Okay, I guess we can try this one. So currently I'm doing a min-max of 3x3 neighborhood, and what they're doing is having a cross, sort of a cross pattern of these 5 taps around the center and blend the neighborhood between these two different shapes, and I guess we can try that. So let me just hoist it out to, no, I don't have to. So I can rename this to the box neighborhood. Um, Alright, and we don't have to waste samples um, since when we're sampling the 3x3 neighborhood, we're going to come across the same taps in here. We can just say check the coordinates, and we can sample sort of both shapes at the same time. So here's the box neighborhood. Here's the cross neighborhood min max. And the one thing we can do is why did you retract the message? So the one thing we can try is, so here, so at least if at least one of the axes is 0, we can say this falls into the cross pattern. And here we can just say neighborhood min, neighborhood max, lerp. So here we're combining the min and max. Let's try run this. Nice. That took quite some time to compile, so I want to do it on a simpler scene first. Okay. So dy unexpected token, right? Don't know what I was thinking. Yeah. Neighbor min. Did I misspell it? Which line was it? What? Now what the fuck is the problem? Line 70 doesn't have neighbor max. I guess I misspelled it. Yeah, this does not look good. It's definitely not what we want. So is there anything I'm missing here? Uh, can you All right. So let me just think here. No, this is right. Yeah, we're definitely doing the right thing here. So something interesting, I guess, is that so in a different part in the paper, it was talking about how it was taking the frontmost velocity, and we aren't doing that currently. We're just taking the velocity of the current pixel. I wonder if that could help. It's a tough problem. So I guess for now we can just remove this. Just have the box. Alright, I mean, I guess it doesn't look that bad. We can leave it in. Let's just forget about the TAA for now. Let's just forget about it. Yeah, maybe sometime later. Okay. I guess the next thing is a proper platform layer. So what I mean by that is Right now you can control the viewport by dragging your mouse across the window. So whenever the mouse clicks down, it registers as you start dragging, and when it lifts inside the window, it stops following the mouse motion. The problem comes when I press down inside the window, I drag outside, and I let go. But basically because that's outside the window, so right now my mouse is lifted, but it's still tracking the mouse. So that's something I have to take care of. So let's see. We can. I think. So what we can do is. So let me just go back to the code. So this is I wrote this in Windows, and in Windows, window messages are handled through a Windows window callback message handler. And in here, what I'm basically saying is that, so you can see, this is the Windows callback function. Here's the message. Here's 2 extra parameters for the message. So whenever a message comes in, say I click mouse, that comes in the form of a Windows message. So mouse move, L button down, L button up. Now the problem is when the mouse is outside the window and I lift it up, these messages don't get sent to the application, so they don't know that mouse is being lifted up. What we want to do is I don't want, actually I want window message active or activate. So what we really want to do is check if the mouse is outside. No, I was thinking about closing the window. Well, closing the window also has a problem, so I guess we can do that first. So WASD controls movement. If I press down move forward and I minimize the window, I open it back up. I'm not pressing W right now, but you can see the camera is still moving. So what we want to do is, whenever the window gets minimized and then brought back up, we want to refresh the input state we have. We don't want to keep having the states what it has before. So for window activate, let me just read deactivated. I guess the deactivated sort of corresponds to the minimization. Mouse activate, that's interesting. Might be something we'll want. Dude, I might have to lift your moderator title if you keep going like this. You might have to ban yourself. Just look at how toxic the chat is. Okay, let me just look at activate. Okay. I mean, I guess we can test it out. Let me just add that to the switch statement. So activate. And here, the low order word specifies whether the window. So I guess W param is I wonder what word. How are they using that? Is a word the 16-bit here, or are they using it as an 8-bit? Because usually D word stands for 4 bytes. So D word means double word. Single word here probably means 2 bytes. So the low order word, I'm guessing it's the lower byte. Whether Windows being activated. Minimize data. Okay. So does it have... So I remember Windows as a macro for, I think, low order word for extracting this sort of thing. Yeah, so it's low word and high word, I believe. Let's see, WinDef. So we have that. Okay, well, what parameter was it? It's wparam. A handler to the window. I guess we don't need lparam for now. We can just look at the message. No. So is deactivated low word wparam equal active or inactive, I guess. So if is deactivated, I guess what we can do is have input struct. That's a global in the SDF engine. Here, where do I have the input? Well, anyways, so these are the state I'm tracking. So keys, if the keys are 0, that means they're not pressed down. If they're positive numbers, then it means they're pressed down. Same thing for the mouse down here. I guess what I can do when it's deactivated, first of all, let's just make sure this thing works. So whenever I deactivate the window, I want to send a message box. Deactivated. What the fuck? Why did it just modify my fucking source code? What the f... Well, I guess it worked. I mean, I did switch out of the window. Okay. Minimize. Okay, that didn't work. Wait, that worked. Okay. Um. Alright, I guess we can say it works. So whenever it deactivates, I want to clear the input struct, which is here. I just have to iterate through all the keys. And reset the mouse down to false, I guess. What's the problem? Oh yeah, Windows, I mean Visual Studio modified my code. Just randomly, just okay. So if it's deactivated, we clear the inputs. So now if we should, let's move back a little bit. Move forward, minimize. Yep, the input got cleared. So here I'm holding down W, minimize, and it doesn't move anymore. This is what we want. Yeah, we will. Maybe next time. This is sort of a, first stream. We wanna minimize the amount of embarrassment. So if I tell them about the stream and people actually join and they watch the stream, my follower count might go from 100 to about 30. Is where I'm guessing. So let's not do that. Um, where was I? Right. So, okay. So we handled another thing, I guess, is so minimize works. So holding on W, if I alt tab, comes back. Yep, the input is cleared. Um, so the next thing, I guess, so let me just clear it out on the to-do list. Refresh states, already done that. Handle mouse moving outside of the screen. Um, yeah, I need to see where that is. So there's a mouse activate. Okay, it's that's irrelevant. Um, I guess like we can read about so the mouse move message. Maybe it has something in there for exiting the window region. Um, let's see. It doesn't have any documentation on that. There's mouse input, um, track mouse movement. Okay, this is what we want then. Track mouse movement, posts messages when the mouse pointer leaves the window. Now, I remember having something like that in a separate program I wrote. I think you have to call this every time. So literally, when the mouse event of the whatever you start tracking gets triggered, this is reset. So you need to call this again whenever the state has been refreshed, which is pretty annoying. I wonder if there's a better way to do this. So let's see. This function calls track mouse event. Oh, that one. Okay. Or I guess it's safer to use this one. Pointer to the mouse event. See what it is. That doesn't really tell me much. So what message does it send me? Let's see. Mouse leave message. Wait, hold on a second. So Windows doesn't send me mouse leave unless I specifically set the track mouse event. Am I understanding this correctly? Hmm. Yeah, this is what I was referring to. Track mouse event is cancelled when message is generated, so we have to do it again. That is very annoying. So we got mouse leave. I guess there's a mouse enter somewhere. Maybe not. I'm not gonna call track. Let's just see if it works without calling the tracking. If mouse leave, we do the same thing, we reset. I guess we're gonna put it in a function now. I can just say refresh input state. In fact, there's no reason why this has to be in the main function. I can put it back to where the input gets defined. Um, oh. Well, fuck it. No. That's the problem. When a mouse leaves window, I probably don't want to reset the keys. So no, that's not what I want to do. All I want to do is just to say mouse down is false. G input, great. Yeah. So G input is the variable. That's the global variable here. Let's try again. Nope. I need a call track event. Oh, this is annoying. So why the fuck do I have to call track mouse event? Why doesn't it just freaking send me the thing? Alright. Why don't we do that? So I guess I'll do track mouse event. And what's the definition of the struct? CB size. Time, we want time leave. So something really stupid we can do is just to call this track mouse event service every single time. I mean, every single time we enter the loop, the game loop, I guess you could call it. Alright, so event to track CB size will be the size of the struct itself, and the flags will be time leave, which will trigger the mouse leave message. Next thing is window to track. It's just gonna be that window we created up here. Hover time. I don't know if you want hover time, but can we put false in here to denote infinite? I guess it doesn't matter because we're calling the service literally every single frame. Do we need something else? Track mouse event. It's in win user included in windows.h. So we should have it. Guess we can try track mouse event. Okay, let's see. Let's see if this works. Yep, this works. Except I'm not too happy with having the tracked event every frame, but it doesn't seem to slow anything down, so that's good. So that's the more proper platform layer out of the way. Next thing is proper CPU and GPU pipelining. I guess I should explain what I mean by that. So let me just go to my rendering code and show you guys what I have right now. Anyways, this is the initialization part that only gets called on first frame. You guys can ignore that. Well, that's a lot of buffers, I know. This is for shader hot loading, so whenever it detects a compute shader has to be written, it has to verify that they're all correct, and if they're all verified, we build a pipeline state object for those different for all the pipelines that uses those shaders. Now camera tracking. Okay, here's the real meat of the engine, I guess. So context, if you know D3, D12, or just general GPU programming knowledge, context, go to utils. Yeah, I have a little utility library for Direct 3 to 12. So a context basically is just a kind of a bundle of everything you need. The device, the command allocator, the command list, or known as the command buffer, the GPU commands, and the command queue is the abstraction of how you would send your command buffer to the GPU. And fence is for synchronization. It tells you whenever the task is finished. So what I'm doing here is basically I'm saying, okay, reset the context. Now we're starting a fresh frame. All these codes are basically inserting commands into the command buffer that will eventually send to the GPU. So this is pure work done on the CPU. Blah blah blah. Special filter, yeah, it's a lot of code. Most of the code are for denoising, because that part is just annoying. Alright, so now we close the command buffer. Basically record a whole bunch of commands. And what we do is execute this command. What this means is that it just means sending the command buffer off to the GPU. It's going to travel from the CPU through the PCIe bus to the GPU, and the GPU is going to start executing these command lists. And present basically, well, it's a function from the swap chain, but what really does is inserting a present command that just tells you to present the current back buffer to the screen. So the reason this is put in here before we wait for GPU, I guess I'll get to in a bit, but the whole point is that this call is kind of I really hate how they abstracted this one. This really should be part of the command list or part of the command queue function, because what it's really doing is just inserting the present command as the last command on the command queue. Okay, so anyways, all you need to know is these are just a bunch of commands I've inserted to the command buffer. Now, wait for GPU. What this does is that telling the CPU, okay, now I've sent off all my commands. I want to wait until the GPU is done so I can start the next frame. I mean, that sounds ostensibly good, right? So what actually, implementation wise, it just updates the fence value. The command queue has a feature of saying you can tell it. So signal means whenever I'm done with all the tasks past this point from which you've called the signal, I will update the fence object to the fence value that you passed me. So basically, I'm just saying update the fence. Update the fence. So the fence object. This is a separate D3D object. This fence value is just an integer. What I want to do is set the value that's inside the fence to be the fence value whenever I'm done. And this is just saying if we're going to wait until the value is being updated. So effectively, we're waiting for the command to be to finish executing. So that's pretty much what's going on in the engine right now. So anyways, that sounds reasonable, right? Well, actually, that's a really bad idea because you're not doing. So you got two units, you got CPU and GPU, but if you structure your workload like this, you're only gonna have one single unit running at the same time. So what really you want to do is on the CPU you build a command buffer. Now as soon as you send that off, as soon as the command buffer goes to the PCIe bus, while it's still traveling to the GPU, you want to start processing the next frame immediately already, so that the CPU can run while the GPU runs. So the ideal situation will be the CPU will be building the command buffer for the current frame while the GPU is chewing away at the command buffer as you sent it from the previous frame. Or you can even have, well, the situation I just described is sort of a double buffering strategy, but you can extend it to like triple buffering, or I guess beyond triple buffering, it's not really useful, but you get the idea. To have multiple frames in flight is what I'm trying to get at here. Um, so that's really the ideal situation we want. Now, we don't have much CPU code here besides the command buffer building, so this might not be worth as much as say it would do for a real game, but building the command buffer itself is pretty damn expensive on the CPU side as well. I mean, it really depends on the driver, I guess, but actually, I guess we can measure it. Hmm. Um, Using a timestamp query. Or was this something else? I forgot what it's I forgot what it's called. Let me just go into one of these. None of these is what I want. Well, timing. This is gonna be the GPU side timing. Never mind. Get. Fuck. What is it? This query counter? Something like that? You know what? I'm gonna be a real peasant. I'm gonna use time.h. Oh, I guess I can use. Let me just read this. I never used the standard library, so gonna need to do some reading. We want precision that's on the order of magnitude of milliseconds, because that's where things get significant. I want to know the precision that the clock gives me. So clocks per second, I guess that has that. I don't know. I don't know if any of you guys know what the precision is for the C++ clock or C, time.h. Oh hey, what's up? I guess I can make you a moderator too. Clocks per seg. Is there any way to figure out in Visual Studio? I guess I can include time.h and try to jump to the file, I guess. Here, let's go to update and render, jumping to the engine. This is the, so everything else is sort of the platform code, and this is the engine itself. So can we? Okay, I guess we can't do that. Well, that's a bummer. Wait, what the fuck am I thinking? I can just define it. I mean, I just freaking. I can just do this, right? And then inspect it in the watch window. I don't have that. Right. Is it clocks or? Yeah, clocks per second. So clocks per second. Dude, come on. So that's literally one clock is, I mean, one clock tick is just 1 millisecond. That's not really, that's pretty damn useless, but uh, I mean, I guess we could. I guess we could do it because it's simple enough. Just try to see if the command buffer building uh, exceeds 1 millimeter, not 1 millimeter, 1 millisecond. Okay, so clock T, begin tick, clock. Just compile, make sure I doing this right. Okay, cool. Now we don't want to insert the end tick there below the GPU because then we're taking into account the GPU time as well. So really, this is what we want to see. So command buffer build time is end tick. Well, not yet. End tick, subtract, begin tick. Now convert that into floating point and divide that by the clocks per sec. And that's gonna be our command buffer build time. I guess we could. Well, whatever. Let's just go into debug. I was thinking printing that in the window title bar, but I just don't want to bother with that right now. Whoa. Okay, so that's about 2 milliseconds, right? It's about 2 milliseconds just to build the command buffer, if I'm not missing anything. Because all this doing is really just building a command buffer. I want to make sure I didn't slip in anything here. I mean, these computations are virtually insignificant. Where the fuck did I start the timer? Yeah. So it's pretty damn expensive. We want to hide this latency. So that pretty much proves that we really need this proper pipelining. The extra 2 milliseconds is a lot when you consider a whole frame buffer. Say if we're targeting 120 hertz, our frame budget is only 8 milliseconds, and this is already taking 2 away from that. I mean 2 milliseconds away from that. It's really bad. What? What's the problem? What seems to be the problem? What's the problem? What's the issue? Syntax. Well, I guess you're offline. So okay, why don't we just get started and start doing that? The proper pipelining. So basically, let me just re-explain what I was trying to do. So right now the CPU gets it's stalling on the CPU builds the command buffer. sends the command buffer to GPU, wait until the GPU is done, and it starts the next frame. We want the CPU to start the next frame immediately after the command buffer departures. To do that, we kind of need, so in wait for GPU, we have the synchronization primitive, which is a fence. So if we want to keep 2 frames, so let's just say we do double buffering, we want to keep 2 frames in flight, we probably need double the amount of synchronization primitives. Plus, one subtlety is that CPU, obviously, it's going to outperform the GPU in terms of how many frames it's able to chew, because all it has to do is to build a command buffer. So there will come a point in time where the CPU is processing ahead of time too much, so it might be trying to build a command list for the frame that the GPU is still working on. Now, how is that possible? It's because the swap chain, well, my swap chain only has 2 back buffers, so when the swap chain is presenting 1 back buffer, or working on the resources that's binded to that back buffer, you can't really send off any more work. I mean, you can't really send off any command list that will... I guess that doesn't make sense. So I guess what I'm trying to say is, let me gather my thoughts here. So we actually could send the command, we can just keep pumping the GPU with our command buffers, but but that has an issue, right? So the problem is, this is kind of implicit, so it was not totally obvious to me. But so what the driver has to do, or what the D3D12 runtime has to do, is you can see, or every time we dispatch something, you have to track all these constants or the descriptor tables I've binded. Now each time I build a command buffer, they have their own versions of the descriptor tables and the constant buffers, because if they don't version the root signatures, well, not the root signatures, more like the root arguments for the compute dispatch, it wouldn't be able to allow multiple frames to be in flight, because frame 0, while it's chewing on something, then if you dispatch frame 1, the frame 1's commands might overwrite the resources that frame 0 is still using, or in our case, it might be we might be required to modify some resources that's local to the CPU, and the GPU is waiting to use for the previous frame. Sorry, if that makes sense. So I guess it's just nice to keep sort of 2 frames max floating. So why don't we do that? So I think it should be quite straightforward to do that. All we have to do is say, so when we present the swap chain, well, instead of wait for GPU, instead that we kind of want to wait for GPU, we want like from an extra argument in this function called frame index. So this is sort of the frame you're waiting for. If we're presenting back buffer 0, then we say wait for GPU 1, because we want GPU, we want frame 1. I mean, we want back buffer 1 to be done processing and start presenting before we work on frame 1 again. Otherwise, if we don't wait for this, we might have conflicting resources, contentions, or we might be processing back buffer 1 a couple frames ahead of time, if that makes sense. Am I coming across here at all? I'm not sure. You know what? I think I'm going to take a break for a little bit. So yeah, I guess I can do this. So note. Okay, I'm back. Can you guys hear me? Alright, so, like I said, what we really want to do is to keep two synchronization primitives in our code, and to do that we sort of need two separate fences, right? One fence waiting for one back buffer. Um, hey Lippet, what's up? Welcome to the stream, man. Alright, so, god damn it, where was I? Yeah, so we're trying to do double buffering so that we can utilize CPU and GPU at the same time. Now where was I? Right, so the utility that I have for the GPU context, so utility is a little nice library I have. It assumes single buffering, which it only has a single fence value, which is not great. So I'm thinking about extending. I guess we could use the same fence value, but we need two separate fence objects and two separate fence events. Alright, so the thing is, the API I have for the utility function sort of locks in a single buffer strategy. So I guess what I want to do first is try to introduce this idea of multi or double buffering. I guess I can introduce a template, which buffer count I'm not a fan of, but sort of fits in well here. Buffer count, and wait for GPU. So instead of waiting for the current frame, what we could do is wait for the previous frame, so that the CPU doesn't stall on the current frame and can start processing the next frame immediately. So to do that, we sort of need a separate. So init context. Where is it? Do I even have a init context function? Yes. Here, create fence. We need. Oh fuck. That means I have to pass template into everything. Yeah, I'm not gonna do that. Fuck that. I guess I could just have to define here back buffer count. Maybe have a 2. Do I already have a back buffer count defined somewhere? Yes. Okay, let me think about how I should do that. Now before I go about that, I just noticed the width and height, so probably want to add to the to-do list. We want window resize full screen handling. It's not really nice to have a fixed resolution. Let's see. So util back buffer count. Oh man. Oh, we also need a separate command allocator. Now it's almost looking like we need two separate. We can have one context per back buffer. Should we do something like that? I'm not sure, to be honest. Um, let's think here. So the command list, the command queue, that can be shared for both frames. So it's fence value. Thinking. So why don't we pull something out here, and we call it frame context? I don't know if that makes sense, but it's the best name I could come up with. So this is sort of what each frame in flight needs. It needs a fence value, and a command allocator separately. Command allocator, we can pull these out and have the frame context, frames in flight, frames. Let's just do two. Let's just do two here. And we can have a separate function for initting the frames. Do I need a separate command? That means I need a separate command list, doesn't it? Why don't we consult the D3D12 programming page? So work submission, executing a synchronized command list. I think that's what we want to see. Hey guys, yeah, it's called 4Coder. So it's a nice little text editor. That's the only reason I use it is because it's really fast and it's really customizable. Alright, let's read about this. Support for multi-parallel command queues. Okay, I guess this is talking about async compute, which is not what we're trying to do. We're just trying to process multiple frames in a flight. So, command list. So I guess the command allocator that gets passed to create command list, the command allocator that gets passed to the create command list call, this doesn't have to stick around for the particular command list that we create it with. I think we can swap out the command allocator in the middle. That should be completely fine. So I'm just gonna do God, I really don't like this name, but I can't think of anything better. Can't type. Context, so copy the code from here. Guess we can define like a frame in flight. Frames in flight have it be 2. And context frames, frame I, init frame context. Probably need to pass the device into. And the create command list, we can just use the first frame's command allocator. That should be fine. Fence value. we need an initial offense value, which I guess we could just zero it. Do I have the fence value initialized anywhere? Hold on a second. Did I mess up? No. The fence value is okay because this is zero initialized. The fence value is initialized with 0. Okay, everything is right. So reset. I guess. So in the GPU context, what we can do is to say so reset. We can have a uint that tells us what's the current back buffer index, and in reset we can update this to current back buffer index equals the swap chain. Do we have the swap chain here? No, we don't. Swap chain is outside, so we could pass it in. Current back buffer index. And we can use this. Damn, that's a long name. I guess we can shorten it to BI, stands for buffer index. That's pretty bad. Okay, so frames BI dot command allocator frames BI. Alright, so reset. Let's change the definitions. Signal fence. So the fence value okay. So we can assume. So let me just go back to code. So you see the way I'm structuring this, right? Execute command list, present, and wait for GPU. So by the time, we can assume that by the time wait GPU is called, so during the interval between GPU context and GPU reset, we can assume that we already kind of flipped a page inside the swap chain, and the back buffer is already like at least to the swap chain's perspective, the back buffer is already onto the next one. So here, what we need to do is signal the fence for the current command queue, obviously, and the fence object we need to signal will be for by this time we're still in frame BI, so we're still in frame BI here. And now the value we want to wait on is the I guess the next frame, right? So for wait for GPU, I guess let's pass in the next back buffer index. So here, what we can do, well, I guess we aren't. Alright, so for reset, there's a function in D3D12 that you can do. So MSDN swap chain get current back buffer index, I think. So we can use this function to get the current back buffer index. Swap chain, I think we have that in the engine struct. So reset the current. So current back buffer index. We do this, and for wait for GPU, I need to change the declaration. This is why I'm sort of experimenting with using member functions instead of just functions outside of the struct. and I was liking it so far until I need to change the signature of functions, which now I'm no longer enjoying this. Okay, so BI, we can pretty much say, we can first assert that BI is no longer next back buffer index. So if we're in a double buffering situation, after we flip the page in the swap chain, the back buffer, the new next back buffer index we get from swap chain is going to be a different page. It's going to be the next page, and because we only have 2 buffers, that's also the previous page. In fact, if we interpret it as the next buffer, we're waiting for the work on the next buffer to be finished. We can even extend this system to triple buffering, I think. So next back buffer index. So now what's nice, if this works, is that, so I record, say we're starting from frame 0, I'm recording the commands for frame 0, I present, the next back buffer is going to be 1. So I'm not waiting for the current command buffer to finish, I'm waiting for the previous command buffer to finish, and by the time it's very likely that it's already, well, it's not likely, but you get to overlap this latency of recording the command buffer. So you hide this latency. The only thing, so instead of your frame time being the sum of your CPU time plus your GPU time, it's going to be the maximum of either CPU time or GPU time. And in this case, since we're doing virtually nothing on the CPU, we're only reducing this execution time of each frame to exactly how much time it takes on the GPU to execute all the commands we send. Alright, so yes, we need to change this. So if BI, so we need to, I guess we don't need to update it. Yeah, it's gonna get reset at the next frame anyways, so we could just, this is a long name. I mean, I can do this, but this is too long for my liking. Also, we need a different fence value. So I guess in the frame, in frame context, we also move the fence value in there. Yeah, we clearly need to step through this code because I've made so many changes that I can't possibly keep track of all of them. So that next back buffer index. I wish there's some next BI. Sorry, this is a really bad name, but it's short. I like it short. Is that how you do it? I mean, I guess I could do this, right? This will make it even shorter. So basically, the next frame is what we anticipate the next frame is going to be. Well, that's, this explanation is kind of redundant. I'm just going to skip that. Reset. Oh boy, this is bad. So, so what's happening here is Okay, so the context is sort of built for rendering. I was being lazy. This code is for uploading the texture. Um, so what I should do is to probably create a separate copy engine besides the 3D graphics engine or the compute engine. But I'm reusing the same GPU context for uploading, and now it's biting me in the ass. I guess, well, I guess I can just set 0 to both of these. Then this assert won't be true anymore, which I really want this assert to be here. Oh god. You know what, fuck it. Let's just say no more assert. So now I guess what's nice is this actually works as a single buffer. You can emulate it as a single buffer context. Huh. Now where was I? Does it all compile? Yeah, well, here's the next part where we run it and it just crashed. So let me just try to go through this mentally, try to see if everything's in check. BI current back buffer. Wait for the GPU. Alright. I think it should be fine. Why don't we step through the code? That'll tell us. That'll be much clearer than me mentally stepping through, because I'm actually physically stepping through the code. Alright, back buffer tags. Cool. I think the first part where we use the context is this load texture, which, let's see. So let us just inspect the state of the context right now. So device command list, the current BI is 0, frame, finds values of both zeros. No cache barrier. These cache barriers are sort of fancy, so I guess I'm going on a side tangent here, but you can see I can do UAV barriers. The thing is, when you do barriers in D3, D12, you don't want to call the barrier API. You don't want to call it like 8 times in a row. You want to merge them into a single list of barriers, and you want to call that through the API just once. This is just a nice helper function that gives a nice imperial API that allows me to stack barriers and dispatch and flush it at once. Let's see. Okay, so let me get to the part where the context is doing something. So reset. So current back buffer index is 0. Command allocator. So frame 0 reset. Command list. Reset frame BI. Alright, we're good so far. Command list. Command Q execute command list. Okay. Wait for GPU at frame 0. Whoa, everything just changed. I think that's a bug in Visual Studio. I don't know why everything just changed. It cannot possibly be that they all get updated by just stepping in this function. So fans value. So frame 0. We're still in frame 0. That's good. Now next frame. We're still in frame 0, and now the next frame's fans value is 1. That's correct. And the complete value. Now we're waiting on the correct fans value with the correct fans object, which is the one we just signaled. So this is all good. The reason it doesn't wait is because I sort of waited a lot of time to step through this. So GPU finished that in time. Cool. I think that worked. Yeah, let me just skip all that. Down here. So swapching, what is the current back buffer index? 0. Surprise. Frames, resetting this frame. Okay, this is all normal. You know, filling in the command buffer, nothing special. Okay, here is back buffer index. I guess I'm calling this again. Am I redefining this variable? Have I tried implementing marching cubes? No, I haven't. So I've heard from different people that some people say marching cubes is really, really easy to implement. Some people say marching cubes is really hard to implement. So are you talking about implementing marching cubes in the context of terrain generation? So I'm not sure. Marching cubes is interesting, but I don't know what kind of the purpose mostly it's been used as. So if you can tell me like an interesting application, maybe that could give me more motivation to look into it. So all right, swap chain present. So hopefully this is 1. Okay, good. It's 1. Swap chain present. So we flip the page to the next buffer. Go to wait for GPU. So hopefully we can skip this, right? So this should be 2 now. What the fuck? Okay. Alright. 65 because I loaded 64 textures. Okay, this makes sense. Actually. 0, frame 0. Fence value 0. Okay. So I was just checking what the next frame will be. So the fence value is 65. Now the command Q will signal the fence for the first frame context. I mean frame 0. Okay, so fence 0 is waiting on frame 0, right? Now next frame is going to be frame 1, and we're waiting on frame 1's fence to reach the fence value 1. Now the thing is, the fence itself is initialized with value 0. So obviously the completed value, this is going to return 0. And this is 0, which means that this is perfect because even the edge case of when the next frame has not even been processed works, because just by the virtue of 0 initialization. So obviously we don't even have to, this condition is vacuously true for the first time. So we don't wait. So you can see for the first frame already we don't have to wait at all. We just skip the waiting part. So now say if I wasn't stepping through the code, the CPU will go on to process frame 1, while the command buffer for frame 0 is getting sent through the PCIe bus to the GPU, and all of this is happening in parallel. This is really nice because we get to use all these different processing units in parallel at the same time. We're not wasting any resources here. Let me just go to the next frame, see if we're doing the same thing. Alright. Did I just skip reset? Oh my fucking god, I need to redo this again. Hopefully it works. I mean, okay, so next buffer should be 0. So now we're signaling frame 1, and we come back before we process next frame because we're double buffering. Remember, now frame 0 is coming back as the next frame. We need to make sure the fence value 65 gets finished, and by this time we already hide. So you can see we sort of put the waiting for GPU part, the synchronization step, to the next frame. And what we have traded is 1 frame of latency. But we hide. No, that's not what we traded. Really, we have like a very small input latency for the double buffering, but we can hide the latency for recording the command buffer every frame, which I think is a win. overall. So yeah, it still works. Well, that's pretty amazing. I did all that change and it actually worked. I think it's slightly faster even. Probably just the placebo effect, but I'm happy with that. So that's one more thing crossed off the to-do list. Window resize full screen. I don't know if I want to go into that. I think something more fun to play around with would be filmic tone mapping. Actually. So I feel like I already did quite a bit of dredge work for the day. I want to do something fun. Maybe directional light source supports? I don't know. So filmic tone mapping. Why don't we do some reading, see what people have done with it. Okay, I remember this is the blog post, that's interesting. We can get rid of all these API lookups now. Okay. So so this is just a gamma correction. Reinhard or Reinhard, I don't know how to say this name. So I think this is what I'm currently doing. I guess it hardly makes a difference. So I have a tone map shader. What it does is so the color, so the rendering engine operates in HDR highly dynamic range color. Now the problem is our display only accepts 8-bit. So this process basically squashes the color space to a low dynamically ranged. So obviously if a number gets divided by a number greater than itself, it falls into the range of 0 and 1. So this is the Reinhard tone mapping part, and this is the square root is approximation of the power function that's listed here. I mean, it's just faster, and I don't think visually it's any different. So this is a color operation we do, and dithering. I think that's also a really very important step. If I don't know if you watched so for the game Inside, they did a GDC talk on that. So the problem is when we squash the color space, if so, for example, in our case, right? Mostly the effect we have here are ambient occlusion, and radially the ambient occlusion is the same. And when we have discretized the ambient occlusion value to 8-bit, this is going to manifest itself as a banding artifact. And to remove the banding artifact, all we have to do is introduce this little random jitter in the color space. So we just randomly say in the same banding, we're randomly lifting pixels up by 1 by 255 so that we turn the banding to noise, and perceptually if there's just one bit different, human eye can't tell the difference, and this solves the banding problem quite nicely. How is DX12 compared to Vulkan in terms of learning curve? I think DX12's learning curve is quite a lot more. I think DX12 is easier in general. Well, the concepts are pretty much the same. It's really, from what I've heard, I've never personally dealt with Vulkan, so take my words with a grain of salt, but Vulkan just seems like a lot of boilerplate setup. In DX12, it's less boilerplate, but you can also expect a lot of boilerplate. I think for a hollow triangle application, you can expect DX12 to be about 500 lines and Vulkan to be about 3,000 lines. But the nice thing about these APIs is once you set up the pipeline, you don't have to do much. You don't have to do much else. So I think Vulkan's learning curve is definitely steeper. Just from the things I've seen, but never personally used it, so no way to be sure. Okay, what is this? That's interesting. I have no idea what this does. I guess we can skip that. We're looking for the filmic Uncharted 2. I guess we could try this one. ABC. So we could try this tone map and see what it looks like. Now before that, it's probably not very interesting to try on the sphere scene. So let's look at the Cornell box scene. So this is the Cornell box scene, and this is what it looks like with Reinhardt tone mapping. Let's try plug in their tone mapping. I'm just trying to understand what this is. Doesn't seem like too big of a difference. I might even prefer the Reinhardt tone mapping, to be honest, which is sort of what we're already doing. Yeah, I think we can. Yeah, I'm not sure if tone mapping is. I think I already have a. I think ours is already good enough, to be honest. So I want to put that off. I guess what we can do, sort of as the last thing, is making one more example scene, which I think is gonna be more fun than doing the rest of the to-do list. So so I have one thing in mind, which is I want to do like a tunnel, because due to SDF's unique property, you can do infinite geometries, and I want to kind of showcase that. So demo, let me just copy everything here, and in scene, let me include that tunnel. Alright, so we won't need the spheres anymore. Actually, let's have just this one sphere. Is it updating? Oh, right, that's... Oh, that's... Okay, the reason it didn't hot load is because I created this file after the application has started running. And it only tracks the code. So on the application startup, it collects all the source code and needs to look at for hot loading, and we have created a file after it's done that. So maybe you want to make a change for that as well. Anyways, I'm just gonna restart the application for now. Okay, so that's tunnel. So what I want to do is let's assign a material for that. Say this is sphere. Say emissions 1. So it's like some sort of light source. Now, obviously for a tunnel, so let's think about how we calculate the distance function for a tunnel. So the cross section of a tunnel, the distance will just be, it's just the distance to the parameter of a circle. So that's literally the length. That's literally the length of the position of the point in y-x plane, right? We can, so yeah, this is easy. So we can just do this. Tunnel length of p dot yx, xy. Then we set a radius here. Actually, it's length, so that's it. Sorry, I'm trying to think here. So we can define a radius, let's say 5, and the problem is this tunnel is just going to be like a cylinder and it's solid, so we can negate it so that we can negate this tunnel value so that we can make a hollow inside, and if we bind the tunnel, what we should be able to see is a sphere in a tunnel. Yep. That's a tunnel. That's a tunnel, alright, but I don't like seeing the light at the end, so you know what, I'll be right back. I'll be right back. Yeah, I just getting a phone call. I need to pick up the phone call now. Alright. I'm back. Can you guys hear me? Okay, at least I can hear myself, so okay, we got this tunnel. that extends infinitely, which is pretty nice. Now, what kind of the problem is that the lighting is too. I mean, the surface is too smooth, so it's really. I would really want to add more complicated BRDFs later on, but right now there's more problems to fix. So this is sort of the temporal filter denoise only, just after the spatial. Just looking at why it's having this boiling, looking at the signal that's coming in. Alright, so let's give the tunnel and the floor a different color. I guess so. For the tunnel, let's make it red. Don't know why it's just a random color. I guess we can play around with this color a little bit. That's a nice color. Yeah, so this is another thing I want to fix. So every time when I have some sort of error, it's a very annoying window pop-up. So I want to have like a nice log message on the screen, except popping into my face every time. Too much red, maybe? Okay, maybe this is the right. Maybe this is the right amount of color. No, that's purple. Okay, and maybe the floor can be darker. Alright, so I don't want to have the sphere here, to be honest. So what I want to do is, the sphere just looks bad. I'm using it as a light source to guide my exploration, but it's about time we'll get rid of it. I'm thinking about having sidelines on tunnels that act as light sources, so let me just try that. So if the positions, we can say, so if the Y position, the absolute value is around 0.1, we can set the emission. So let's get rid of the sphere, let's see what it looks like. Not bad. We could use some more, we can use some more emission. Yeah. I think the this looks, I don't know, this looks quite bad. So maybe I want to up it a little bit. Something like this. I can lower the emission value. I'm not sure if we still need the sphere here. So I guess another thing is I don't like how I can see all the way to the end of the tunnel. So what I'm going to do is, so there's a constant I can tweak Tmax, so I can have it to be a little farther, but that doesn't solve the problem completely. What I can do though is a path trace or primarily surface shading. What I can say is that I want to have attenuation. This is sort of the fog, so the farther away the surface is, the less amount of light I get out of it. So this sort of gives, oh, it's too much of cutoff. No, that's not nice. Holy crap. Guess I don't want this power of 1. What's the problem here? This is really sharp. It's like a really sharp fall off. I want it to be like a gradual, a gradual attenuation. So let's try. So let's see what this looks like. Okay, I think that's a little better. Okay, but we still get to see. Let me try to clamp the attenuation in 0.1. Okay, I guess this is just what it's gonna look like because it's too. Huh. Yeah, I don't know. Alright, this at least it looks better than what we had before. Alright. So the next thing I want to do is add. Let's go back to our scene. Go back to a tunnel. I want to add some bumps on the surfaces. So I'm borrowing like a hash function, having another scene. So this is sort of the power of sign distance field. You can really play around with the shapes quite easily. So include all these files. Okay, it works. Now the magical part is that for the floor we can literally just add let's say FBM. Cool. Does it work? Oh boy, it's really slow. Let's try a little higher. Alright, now we're definitely seeing the bumps. I don't know if you can. But this looks pretty goddamn cool, I think. Now the issue is our FBM is 3-dimensional. What that means... Oh god. Oh, right. Oh. Okay, this is okay, I know what's going on here. So there's one problem we forgot to address when we were doing GPU CPU pipelining. So every frame when we come back. So the problem is when a frame with double buffering, now we have potentially any number of frames in flight. The complication that adds on top of that is whenever we do this, it's possible that we're releasing a pipeline state object while the previous frame that's executing is still referencing the pipeline state object that we're releasing. So what we need to do here is, if we need to reload, what we want is something like context flush frames in flight. So what we want to do really is to make sure all the frames that are in flight that might be referencing these pipeline state objects are done processing. So it's really equivalent to what we were doing before, which is single buffering. So have the CPU completely stalling out the GPU, and then we can safely proceed with modifying the pipeline, the compute shaders. Well, too bad we don't have this function yet. We can implement one though. Utils. Flush frames in flight. So GPU context. So what we can do is we can sort of borrow what they have. We can just say, okay, I want to iterate over all the. So I want to iterate over all the frames in flight, right? And I just want to say for all the frames, I want to stall the CPU until the fence value is being updated, meaning that all the work on the GPU is being finished processing. It's not really next frame anymore, it's just frame. The fuck? What's your problem? Oh. That should be it. So we can, so yeah. Every time we're flushing flight, let's just test that out. Tunnel, let's say we add yeah, seems to load just fine. So I want to stress test it with a very expensive FPM. Well, that seriously looks cool. Okay, but it works. It's performing under stress, which is good. So I guess, what can we do for the tunnel? So something I want to have is on a tunnel, I want to have like a, so what I want to have is a yellow stripe going down in the middle, like a roadie drive, just to add more element into the scene. So if position Y, matte albedo, I forgot what the RGB color for yellow is, but certainly not this. Oh, it's X. So now we have a yellow line going down. How wide do we want this to be? Maybe like this. Actually, I can get the sphere out of the way. It's kind of blocking my view here. Yeah, this is a nice color. Kind of hit the jackpot, I guess. This might be better. I don't know. So I want to have, so this is just one straight line. I want to have like a dashed line. There's breaks in the middle. Let's see how we can do that. Let's say, so I can add one more condition. So it's z-axis going down, so we can do frac pz less than 0.8. Let's try that. Okay, that's a bit better, but the frequency that's being broken up on is too high. So what we want, I guess we can just stretch the space in which we test this. That made it worse. Okay, that's much better. That's sort of what I was envisioning. So we got, I don't know, does this look right to you? Does this look good? Maybe a little too, okay. I can't tell. The problem is I don't drive, so I don't know if this is right. What if it's all white? Let's see what happens. Yeah, I like the yellow more. Yeah, I'm driving down in a tunnel. Pretty cool. Now, another thing is, so we don't have, usually we don't have perfectly shaped, I don't know if you would call this, So usually there's some kind of deterioration in the painting. We can emulate that inside distance field or the procedural material creation just fine. What we can do is using FBM now. They're all three-dimensional and they're very expensive. I don't like that. So let me just create a two-dimensional variant of the FBM function so I can use that for texturing. ABCD, it's all we need. See, we cut the computation in half already. So we can create a hash function too, which is I guess we can remove the last element. Hash dot, that should be fine. Yeah. Alright. So hash 2, unpause, and these are just float 2s now. Well, I guess I should explain what noise function is. So noise is just a Perling noise, something like that, and FBM stands for fractal Brownian motion. It's fractal Brownian motion is different layers of the noise, so it just means you're layering noise at different frequency on top of each other, and with each increasing frequency you're halving the amplitude or the influence of that layer of noise on the total FBM. So it's sort of the fundamentals of fractal, you could say. So it's creating like a fractal noise. I'll show you what that looks like in a second. So we don't have TZ anymore. So we float 2, let's just make sure this compiles. Yes, it does. FBM, now it's trivial to make FBM 2 because we have noise too. Now that worries me a little bit because this noise function shouldn't compile. So I think the compiler is just skipping compilation. So once we actually use FBM2, it might not be what we want. So okay, so I want to add some deterioration to the painting. What I can do here is I can add like an FBM value. So FBM2 p.xc. Let's see what that looks like. If that compiles at all. Yeah, there's some deterioration. So I think the problem is, since we're scaling the position on z-axis axis differently, we need to sort of match the scaling we have. So p.x and 0.1 p.z. Let's if I do that, it's a little too much. So I guess we really want to up the frequency a little bit for the noise. That's too much. Okay, maybe that's just right. Or maybe the noise function that I have is not quite good. What if I just have noise? Okay, never mind. FBM is definitely what I want. Yeah, maybe the noise function I have is just not fantastic. I don't know, does this pass? Is it? It's too much deterioration, I guess. I guess we can sort of do this. Let me just change the hash function. No, it doesn't make too much difference. Alright, let's just call this the road for now. I guess the next thing I want to do is having these be laid out as bricks. Now this is a little bit challenging because we're actually doing some non-trivial procedural modeling. So let me think about how we should go about this. Um, hmm. Um, okay, so my idea is converting the positions from Cartesian coordinate to polar coordinate, and we modulate the distance in polar coordinate and convert it back to Cartesian coordinate. I don't know. I'm not sure if that will work. But it's definitely going to be easier than doing this in Cartesian space. Um, so what if we hmm so yeah, I'm not sure how we can go about this. Since it's a so if we're going to convert it to polar coordinates, it's gotta be with respect to something. Um, yeah, I didn't expect it to be such a tough problem. XZ, I guess there's. I mean, I guess we can try add an FBM on top of the tunnel, see what that looks like. Um, so that'll be X, no, not X, so Y and Z. Oh man, it's already slower. I think that looks quite cool. Pretty goddamn fucking cool, I think. So I might just keep that. If it wasn't for the fact that it's so goddamn slow. I might have to come up with a way to optimize this. So the remarching loop and the fractal Brownian motion implementation, but damn, you can really look at the surface details. It's really quite nice. So I don't know, maybe that was too slow. You know what? I guess I'm just gonna call it at the end of the stream for now. Maybe I'll leave it as next time, but for now the tunnel is just gonna look like this. This isn't that bad, I guess. So let me just remove the primary shading because I don't want the attenuation to affect other scenes. So this is sort of what it looks like now. Alrighty. So yeah, this is gonna be the end of the stream. If you're still watching, what does SDF stand for? SDF stands for Signed Distance Field. You can find more information on that. So I can show you. That's not really what we want. So I guess you can go to Inigo Quilled's website. Here's a bunch of articles on that, on the sign distance field. So what sign distance field, basically you just take it's a function that inputs a 3D position and outputs a scalar. The 3D position, the meaning of it is just that the function computes the sign distance from this position that you inputted to the closest point on the surface of the object, or as you can call it, isosurface. And the sign part is just that when the point is inside an object, the distance will be negative. So that's useful for compositing different sign distance functions. Yeah, so this is a good website you can look into if you want to check out more sign distance function related stuff. Alright, anyways, I'm really hungry, so I'm going to end the stream now. Yeah, thanks everybody for tuning in. See you guys next time.